All right, today we're going to decode the digital doorman. We're talking about your first and maybe your most important line of defense online. I mean, really think about it for a second. Every single time you go online, you're basically opening a door from your private, personal device to, well, the entire world. It's just this constant, endless stream of data flowing back and forth. And let's be honest, a whole lot of that data is stuff you absolutely do not want anywhere near your computer. Well, that's where the firewall comes in. And, getting a grip on what a firewall actually does, and just as importantly, what it can't do, that's one of the most fundamental things you can learn about digital security. So let's dive in and take a closer look. Okay, so let's start with the big picture, the digital front door. Really, the absolute best way to think about a firewall is to picture it as a security guard for your entire network. It's that person standing at your digital front door, deciding who gets in and who gets told to beat it. So this guard, this firewall, it sits right on the edge of your network. It's the one and only point of entry between the wild, chaotic internet and all of your protected, private devices. Everything, and I mean everything, coming in or going out has to get past this guard first. And that's the whole point, right? A firewall's main job is to create a bottleneck, what we call a choke point. By forcing all that traffic through this one spot, it gets the chance to inspect these things called data packets. Just think of them as tiny digital envelopes carrying all your internet messages. The firewall looks at them and makes a call. Does this get forwarded, or do we filter it out and throw it away? And that control is incredibly powerful. A good firewall can keep a log of who's trying to get into your network. It could enforce really strict rules about what kinds of services are even allowed. It can even sound an alarm, send you an alert if it spots something fishy going on. It really is your strongest first line of defense at the perimeter. Okay, and this is a big but. It's not a silver bullet. A firewall can't do everything. For example, it's totally useless against an attack that comes from inside your network. Think a disgruntled employee who already has access. It also can't do a thing about someone walking up to a computer and plugging in an infected USB stick, right? That completely bypasses the network. And yeah, while it can block some bad stuff, there's just no way it can catch every single new virus that's cleverly hidden inside a file that otherwise looks totally fine. So you know how not all security guards are the same, right? You've got the guy who just glances at IDs at the door, and then you've got the one who does a full, detailed pat-down. Well, firewalls are exactly the same. They come in different flavors with different skills. So let's meet this team of security guards. All right, first up, we've got the most basic type, the packet filter. The best way to picture this one? Think of the bouncer at a nightclub. Now, this bouncer's job is pretty straightforward. It just looks at the header of each data packet that's like checking the ID. It's looking for two main things: the source and destination IP addresses, the digital street addresses, and the port number it wants to use, which is kind of like the specific door number at that address. And here's the key. It does this for every single packet, one by one, with absolutely no memory of what came before. It's a very in-the-moment kind of security. And this bouncer, he's working from a very strict, very specific rule book. Like, look at this first rule here. It basically says, hey, if a packet shows up at interface 1 and it's coming from an IP address that starts with 131.34, let it in. The little stars, the asterisks, they just mean I don't care about the port or where it's going. It's super fast, super simple. It's just a check against a pre-approved guest list. And this is the key difference, right here, in a nutshell. A packet filter just checks the address on the outside of the envelope. But the next type of firewall we're going to look at, the application proxy, it goes a step further. It actually opens the envelope and reads the letter inside. Huge difference. So let's meet that more sophisticated guard. This is the application gateway, or as it's more commonly known, a proxy. Now, we're not talking about a bouncer anymore. Think of this one as a very professional, very meticulous concierge at a fancy hotel. See, a proxy doesn't just wave you through the door. When you try to send a request out to the internet, the proxy intercepts it. It takes it from you and inspects the whole thing, top to bottom. And it's smart. It understands the specific language of what you're doing, like HTTP for web browsing. Only if it decides your request is safe does the proxy then go and make a totally separate brand new connection to the destination for you. The crucial part is you never make direct contact with the outside internet. The proxy does it all on your behalf. So let's walk through that. a request comes in from the internet and hits the proxy firewall. The proxy takes a deep look at all those HTTP packets. If it sees any errors or anything that looks malicious, nope, it gets rejected. But if everything checks out, it forwards only the accepted packets on to the internal server. It's just like that mailroom clerk who opens and checks every single package before he'll even think about delivering it inside the building. Now, there is a third type that's worth a quick mention, the circuit gateway. The best analogy for this one is an old-school telephone switchboard operator. This operator doesn't listen in on your conversation, meaning it doesn't actually inspect your data. It just makes sure the handshake, the connection itself, is legit before patching you through. It basically sets up two separate connections and just relays the traffic between them. Okay, so we've met our security guards, from the simple bouncer to the fancy concierge. But what about their rulebook? What does that instruction manual actually look like in the real world? Well, for a huge number of systems out there, especially anything running Linux, the answer is a super powerful tool called IP tables. IP tables is basically the engine, the framework that lets a system administrator write those incredibly detailed rulebooks we've been talking about. It's not some add-on program. It's built right into the core, the kernel of the Linux operating system. And it gives you this amazing, fine-grained control over exactly how every single data packet is treated. So this diagram here kind of maps out that packet's journey. And yeah, it looks complicated, but here's the gist. When a packet arrives, IP tables does a check. That's pre-routing. Then it decides where it needs to go. Then it runs it through the main rulebook, the filters. And finally, before the packet leaves, it does one last check, post-routing. The point is, at every single step of the way, there's a chance to inspect and control that traffic. And after going through all of those checks, every packet gets a final verdict. We call this a target. If the target is accept, great, the packet is good to go, let it pass. If the target is drop, the packet is just silently deleted. The sender has no idea it was even blocked. It's like it just vanished into a black hole. And then there's reject. This also blocks the packet, but it's polite about it. It sends an error message back saying, sorry, connection refused. So there you have it. From the simple bouncer just checking IDs to the meticulous concierge inspecting every detail, firewalls are the essential gatekeepers for our digital lives. They're on duty 24/7, making millions of these tiny, split-second decisions, all based on a rulebook that we get to write. So it leaves you with one really important question. Who's protecting your digital front door?